Akash from SVC College. So today's topic is hybrid systems. That is from SEC subject, Software Evolution and Computing subject. So let's get into the topic. What is hybrid system? So at first, a hybrid system is an intelligent system combining a two intelligent technologies like fuzzy logic, neural networks, and genetic algorithms, and reinforcement learning, etc., providing extent capabilities to reason and learn an uncertainty environment. So there are three types of hybrid systems. So they are new Neuro-Fuzzy Hybrid system, Neurogenetic Hybrid system, Fuzzy Genetic Hybrid system. So at first, let's go through the Neuro-Fuzzy Hybrid system. At first, let's go through the definition, basic definition. Neuro-Fuzzy system is an intelligent fuzzy system, logic and neural theories. It functions as a three-layer feed-forward neural network: input, hidden, and representation, fuzzy rules, and output layer. So basic workflow of the is input layer transmits the crisp signal to the next layer, and fuzzification neurons determine the input membership to fuzzy sets. Fuzzy rules layer represents a fuzzy set. Output neuron combines input using a fuzzy operation union, and defuzzification neurons represents a signal output. So these are the basic applications: student modeling, medical systems, and traffic control system, and forecasting and prediction. So next we have the advantages and the disadvantages. So in the advantages, it can handle numeric, linguistic, logic, etc. Kind of information. It can manage imprecise, partial, vague, and imperfect information. It can resolve a conflict by collaboration and aggregation. It can and it has a self-learning and self-organizing and self-tuning capabilities. It can mimic the human decision-making process. So when it comes to decision disadvantages, hard to develop a model from fuzzy system, problems of finding a suitable membership values of a fuzzy system, and neural network cannot be used in training data is not valid. So in the next we have the neurogenetic hybrid system. A neurogenetic hybrid system, it combines a neural network and genetic algorithms. Genetic algorithm optimizes our neural network parameters, including connection weights, topology, and control parameters. So that is a basic workflow which is represented in the diagram. Workflow. Genetic algorithm modifies a workflow. Genetic algorithm modifies a population of a solution, selection, crossover, and a manipulation creates a next generation. The next generation gives an input to the ANN model. ANN calculates the fitness. That's the basic workflow. And when it comes to applications, face recognition, DNA matching, animal and human research and behavior system. And next we have the advantages and the disadvantages. In advantages, GA genetic algorithm is used in the topology optimization, that is to select the number of hidden layers and the number of nodes and interconnection patterns for the ANN. In GA, the learning of ANN is formulated as a way optimization problem, usually using a inverse mean square error as a fitness measure. Control parameters such as a learning parameter, moment, rate, or a tolerance level, etc., are also optimized using GA. It can mimic the human decision making process. Disadvantages. So, highly complex system, the accuracy of the system is independent on initial population, and maintenance cost is very high. So, this is a last one, hybrid system. Fuzzy genetic hybrid system. Fuzzy genetic hybrid system. It combines a fuzzy logic technique and a genetic algorithm and utilizes a genetic algorithm to optimize a fuzzy rules based and membership functions. So three approaches that can be used to develop such approaches. mimicking approach and Pittsburgh approach and IRL approach. So this is a basic workflow explained that is representing in the diagram. At first we have GA based tuning and the knowledge based tuning which comes under the offline processing. In the online processing we have the input fuzzy logic controller and the output, and it comes to workflow, it starts with an initial population of a solution that represents a first generation. Next, it feeds each chromosome from the population into fuzzy logic controller and compute the performance index. Create a next generation using an evolution operator till the condition is met. Then it gives a output. When it comes to application, there are four applications: mechanical engineering, electrical engineering, and artificial intelligence and economics. So at last we have the advantages and the disadvantages. In the advantages we have genetic algorithms are used to develop the best set of rules to be used by fuzzy inference engine, and genetic algorithms are used to optimize the choice of membership functions. A fuzzy genetic is a direct random search over all received fuzzy subsets. It can mimic the human decision making process. So next we have the disadvantages. Interruption of the result is difficult. Difficult to build a membership values and the rules. Takes a lot of time to coverage. So that's all.